Hi, I'm Brandon Ordoñez from ECE31, and today I'm going to perform our experiment number 2 for our Digital Electronics 2 laboratory, which is entitled Digital Output. The objectives of this experiment are to learn how to create a project and build a project, to understand how the final code is programmed to the microcontroller, to create a simple code for controlling an LED. So let us now proceed with the experiment. First is to open MPLAB Xide. Then create new project. Select microchip embedded standalone project. Here we type PIC 16F18875. PIC 16F18875. Next, select compiler toolchain Xide. Project name Ordoñez _ experiment 1. And create new folder. Experiment 1. Then click finish. Afterwards, we will click Tools, Embedded, MPLAB Code Configurator. And save. Next up, we will use port A4. After clicking the output under 4, the button should turn green, and the button above it should turn yellow. And then, let's select pin module. Custom name is LED_D2, uncheck analog, and WPU. Then back to system module. The oscillator select should be HPin TOSC. The high frequency internal clock should be 4 MHz. Clock divider 4, and the low voltage programming enabled should be checked. Afterwards, we will click generate and wait until configuration is generated. Afterwards, we will click projects, source files, main C. Then we will type the code here, __delay_ms. For the output, for the first output, we expect it to be lit for 250 milliseconds. Then type the name of your LED diode. From here, we use LED_D2. So we would use it here. _toggle. Now, we would build. Now that the program is built, we would move to MPLAB IPE. So let's open MPLAB IPE. After opening the MPLAB IPE, the home screen would appear. So first, let us go to the hardware part of this experiment. So before programming our integrated circuit, let us first be familiar with the parts of the PIC kit 3. So first, let us connect it to our personal computer. A USB cable was used to connect the PIC kit 3 to our computer. You could see 3 light indicators for the power, the active status, and the status bar. Here, the lanyard loop can be seen, And here, the programming connectors would be connected. Now let us, using this tool, we would be able to attach our IC. First, make sure that the lever is pulled upwards, because initially your lever would be placed like this. Pull the lever upwards so that you can insert the integrated circuit here. Now, let us put our ICs. Remember to put the U portion on the lever side. Lock it. And then use the provided connector to connect the integrated circuit to your P-kit. Remember to place the black connecting wire on the MCLR panel. Therefore, the black connecting wire should be connected on the side of the P-kit with the arrow. So, now let us go back to programming the P-kit. Now that we have connected our P-kit 3, we could see from the tool part that it has been recognized by the system. Before proceeding, remember to put the type of integrated circuit used for the experiment. The type of integrated circuit used for the experiment is PIC 16F18875. Now, click Connect. Click OK. From here, we could see that a warning is shown. Target device was not found. Provide a solution, go to Settings, Advanced Mode. Password is microchip by default. And then go to the power settings, voltage level, change it to 3.125. Power target, check. Now, go to operate and look for the hex file. The hex file would be where you initially saved your document, your MPLAB Xide project. After opening the folder, click Disk, Default, Production, and your hex file should appear here. After the hex file is loaded successfully, click Program. Click OK. And from here, we could see that programming is successful. Now let us try to place the integrated circuit on an actual circuit. Before disconnecting your P-kit 3 from your computer, remember to disconnect. And then you're all set to place the integrated circuit on your breadboard. Alright, now that we are finished programming, you can now disconnect your P-kit from your computer and pull the lever up. The integrated circuit came off easily from the P-kit. Now let us place the integrated circuit on our breadboard. Now, we could see from the pin configuration of the PIC 16 F18875 that our output would be at pin 6. For the output, we would use a resistor. For the resistor, we use a 380 ohm resistor. And then we would connect an LED color of your choice. And connect it to the ground. Next, after connecting pin 6 to your output and your output to the ground, first note that we used pin 6 since this is the port A, fourth port A output pin we used while programming the circuit. And then connect all your VDDs to the positive side of your source. So the VDD would be on pins 11 and 32. So again, let us connect first your pin 6 to your output. We used pin 6 because it is labeled as RA4 from our circuit schematic, from the schematic of the integrated circuit. Remember that we used RA4 during our programming method. We used port A4 for the integrated circuit as the output. And then place the VDD on the positive side, which is pin 11 and pin 32. And then connect all VSS to the negative terminal of your source. The VSS are on pins 12 and pin 31. And then lastly, connect your 5-volt source positive red and negative black. Check VSS, 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 negative, VSS, negative, VDD, positive, VDD, positive, output, ground, negative, positive. And then let us connect our 5-volt source. From here, upon turning off the light, you could see that our LED turns on after every 250 milliseconds. The next part of the experiment would be changing the code so that the light turns on after every 2 seconds. So 2 seconds is equal to 2000 milliseconds. And then you just click build. Then after build is successful, yes, reload hex file. And then we would connect first our PIC kit again back to our PC. Now we would connect our integrated circuit to our PIC kit 3. So let us put these aside first. And get our PIC kit. Again, same as what we've done earlier. Load your integrated circuit and connect your PIC kit. Now that we have connected our PIC to our PC, go to MPLAB IPE and check your data and connect. Okay. Just to make sure, reload your hex file back to the home page and click program. Here we could see that programming is complete. So once again, let us proceed to connecting the integrated circuit to our breadboard. Now let us disconnect our integrated circuit from our PIC kit. Let's pull it out and unload. Let's get back our circuit materials. And connect our integrated circuit once again. Now before connecting our wire, check negative, ground, VSS, VSS, positive, and VDD, and another VDD. We are sure of the placing of the wire since we placed the integrated circuit previously on the first column. And once again, we placed the integrated circuit, the first pin of the integrated circuit on the first column. Now let us connect the 5-volt wire and turn off the light. One, two, 1, 2, 1, 2, 1, 2, 1, 2. We could see that our LED turns on and turns off after every 2 seconds or 2000 milliseconds. These are the conclusions and recommendations for this experiment. As observed from the procedure, this is the flow of process on which the experiment is performed. First, coding is performed using MPLAB Xide, wherein you designate what type of output or input that you're gonna program on your microcontroller. Next is programming. This is a process where we transfer the coded program into our microcontroller or our integrated circuit. Programming is done to the microcontroller by the software MPLAB Xide. Lastly is circuit application, wherein you put your microcontroller on an actual circuit and see its results if it reflects to the coded program. Conclusion and recommendations. The experiment had enabled the use of PIC3 and a PIC16F18875 for development of basic knowledge on the software MPLAB Xide and MPLAB Xipe. It followed the procedure of proper coding to be able to set a desired delay time for the output of the circuit, which is the LED. The LED was set to have a delay time of 250 milliseconds for the first part and a delay of 2 seconds or 2000 milliseconds for the second part of the experiment. MPLAB Xide deals with the coding language used to achieve a desired output for a PIC integrated circuit, while MPLAB Xipe dealt with transferring a coded hex file to the integrated circuit being used. I recommend that you use a breadboard with column markings for convenience when it comes to placing your wires for the pins of the integrated circuit. I also recommend that you check the wired connections before plugging in your power source to reduce hazards and damage to your components.